if I tell this example, I know that all of you have done it. All of you have try to balance a book in one finger, right? Now, which point do you take when you want to balance the whole book? You take the center point, correct? So here, see, even with one finger, you can actually hold the whole book, correct? So we can say that all the mass is concentrated at this point, correct? So this particular point is what we call as center of mass. Okay. Now we learned about different types of motions in the last video, right? Now how center of mass will change or vary when these type of motions will happen. Okay. Now consider this particular figure. See, we have A, B, C, A dash, B dash, C dash, correct? So here what's happening is we are moving A, B, C to A dash, B dash, C dash. So here A dash is equal to B dash is equal to C dash, correct? Meaning the whole body is moving, right? Now consider one more example. See here, we have A dash, B dash, C dash. See here, rotation is also happening, correct? So in this case, if you look at it, is A dash, B dash and C dash, are they equal? No, looking at only we can directly tell, correct? See, in this particular scenario, so we are moving the object and we are rotating the object, right? So let's say it's starting from t is equal to 0 to sometime t is equal to t seconds. Okay. So in this particular scenario, A dash is not equal to B dash, not equal to C dash, right? Meaning the positions of A, B, C, it has changed, correct? Unlike the previous example. So here what we say is, even though the positions, each individual positions of A, B, C has changed, we say that the overall translatory motion of the body, the overall, okay, so that is constant or it remains the same. Okay, now how we tell that is based on a particular point called a center of mass. Okay, so the center of mass plays a very, very important part. Like we actually use it every day. Okay, I'll give you certain examples where you can relate it. So first let's see what is the definition of center of mass. Okay, so we say that the center of mass is defined as the representative point of body which describes the overall translatory motion of the body, even if it vibrates or rotates, and it may be regarded that whole mass of the body is concentrated at the point and all the external forces are acting at that point. Okay, so I'll repeat the definition again. So what we say is the center of mass is defined as the representative point of the body which describes the overall translatory motion of the body, even if it vibrates or rotates, and it also may be regarded that whole mass of the body is concentrated at that particular point and external forces are acting on the point. Okay, so the definition is very clear, like the entire mass of the body is concentrated at that particular point. That's why we are able to lift the book with one finger, right? So at that particular point, the center, you can lift it. See, we have done the same thing even for a scale, for a ruler, correct? For a ruler or a pen or a pencil, we hold the scale or the pen or pencil at the middle, correct? So we hold it at the middle and then we can balance it out. Now, simple example, suppose let's say you have a pen with the pen cap, then we shift wherever we are holding the finger, right? Now, why does that happen? Because wherever the mass is concentrated or wherever there is lesser mass or greater mass, the center of mass will shift. Okay, so if we have equal mass, okay, then also the center of mass will be the exact midpoint between the two things. This is what is happening with the book. So when you take a book, then all the, see, wherever you go, the mass is the same. Like if I divide it into 4 parts, it's a 4 equal parts, then all the 4 parts will be of equal mass. So we take the center where all those parts, wherever they, you can say they meet. Just like what we can say is origin and the 4 quadrants. Okay. So now when we talk about the center of mass, see, let's consider, see, look at the figure. we have some point x1 and y1, the distance is x1, y1, the mass is m1 and m2. Okay, so let's say instead of y1 we'll take it as x2. Okay, just to be sure that it's x1 and x2, like, because we're talking about in x-axis, correct? So we have x1, x2 and then m1, m2. Now from the origin, the center of mass is given by m1 x1 plus m2 x2 divided by m1 plus m2. Okay, so this gives us how much is the center of mass from the origin. Okay, now if let's say there are n number of points, then we have m1 x1 plus m2 x2 plus m3 x3, so on and so forth till mn xn divided by m1 plus m2 plus m3 till mn. Okay, in short form we can write this as sigma mi xi, where I is equal to 1 to n, divided by sigma mi, where I is equal to 1 to n. This is nothing but a notation, correct? See, what we did is just for the x coordinate. Now same thing we can do for y coordinate also, right? So we'll get m1 y1 plus m2 y2 plus m3 y3 till mn yn divided by m1 plus m2 plus m3 till mn. Same way sigma notation will also come. Similarly to the z1. Okay, so this gives us the coordinate of the center of mass, even if it is in a 3-dimension, like x, y and z, correct? So always remember, the center of mass is a point where overall mass is concentrated. Okay, overall mass is concentrated. Like if you move the object, even the center of mass also moves. Alright, now one more important point is, this is quite important, the center of mass always need not be inside the object. Okay, there are certain examples, there are certain figures where the center of mass will lie outside the figure. Okay, so I want you guys to go look around how, like, what are these objects, how the objects will look like, because clearly the center of mass depends on the shape of the figure and even the size of the figure, correct? So I want you guys to go look through different types of figures and structures where the center of mass lies outside the figure. Okay, and again I'll repeat, center of mass is where the overall mass is concentrated, and this particular, the formula for this is given by sigma mi xi divided by sigma mi, and sigma mi yi divided by sigma mi, and sigma mi zi divided by sigma mi. Okay, so this is center of mass. In the next video you will see different types of formulas and mathematical relations related to center of mass.